Good morning, students. This is Latif sir. Today I am going to discuss about the chapter 12 of class 11th chemistry. The topic is organic chemistry, some basic principle and techniques. Some basic principle and techniques. So what is organic chemistry? It is a branch of chemistry which deals with hydrocarbons and their derivatives. So the branch of chemistry which deals with hydrocarbon and their derivative is called organic chemistry. And due to two special characteristic or properties of carbon, that is catenation properties and tetravalency, carbon forms large number of organic compounds. Open chain structure, branch chain and ring compounds. Large number of organic compounds are formed because of two special properties of carbon, which are catenation property and tetravalency. And all this you have already studied in class 10 about what is organic chemistry, what is catenation property, what is tetravalency. You know that. Okay, and functional group you have also already studied in class 10. So you have to read this topic thoroughly. Okay, and homologous series, all this topic you have already studied in class 10. So functional group, what are functional group? An atom or a group of atoms joined in a specific manner which provides certain characteristic chemical properties of organic compounds, and these are called functional group. For example, carboxylic acid group COOH, alcohol functional group OH, aldehyde CHO, these are functional group. And homologous series and homologs, a group of series of an organic compounds which each containing a characteristic functional group from a homologous series, and the member of this series are called homologs. Now types in this chapter you have to read about types of organic reactions. There are mainly 4 types of organic reaction. One is combination substitution reaction, second one is elimination reaction, and rearrangement reaction. Okay, so this you have to read about this reaction in class 12th. Okay, just remember the term. Like inorganic reaction, there are different types of organic reaction: substitution reaction, elimination reaction, and rearrangement reaction. Okay, first you have to read about types of fission of a covalent bond. First one is homolytic cleavage or fission. Homolytic cleavage, in this cleavage, one of the electrons of the shared pair in a covalent bond goes with each of the bonded atoms. You can see it is represented like this. You can see in Cl2 molecule, the Cl-Cl bond, Cl-Cl covalent bond homolytically cleaved to give to Cl radical, and these are called free radical. And heterolytic cleavage, in heterolytic cleavage the bond breaks in such a fashion that the shared pair of electrons remain with one of the fragment. Okay, in CH3Cl, Cl accept or get both the electrons. That's why Cl becomes negatively charged, Cl minus, that is anion, and as CH3 loses its one electron, it is converted into CH3 plus. Okay, and due to such type of bond cleavage, heterolytic cleavage, you will always get cation and anion, that is ions. Okay, and you know negatively charged ions are also called nucleophile having excess electron, and electrophile that is positively charged, and sometimes electrophile also neutral like VF3. Generally electrophile means positively charged positively charged ions are known as electrophile, and negatively charged ions are generally known as nucleophile. And electrophile, they have incomplete octet. Electrophile. Now electron displacement effect in covalent bond. So it is written as bovalent, it is actually covalent bonds. Electron displacement effects in covalent bonds. You have to read about 4 types of electron displacement effects. First one, inductive effect. So what is inductive effect? Polarization of a bond caused by the polarization of adjacent bond is referred to as the inductive effect. Polarization of a bond caused by the polarization of adjacent bond is referred to as inductive effect. Two type of inductive effect are, one is plus I inductive effect, that plus inductive effect or plus I effect, and minus inductive effect or minus I effect. Okay, an inductive effect generally represented like this: CH3, CH2, CH2, Cl. In this compound, Cl pulls the electron from carbon. Okay, so Cl above the Cl develops some negative charge, and carbon develops positive charge, because Cl is more electronegative than carbon. Okay, so inductive effect is caused by the difference in electronegativity of the bonded atom. Here some inductive effect of some groups are given. Minus I effect, generally negative electronegative element, they have minus I effect. Okay, so minus I effect, the group having minus I effect are NO2, F, Cl, Br, I, OC series, and benzene. Okay, so you have to remember the order. Okay, NO2 greater than F, greater than Cl, greater than Br, greater than I, greater than OCH3, greater than C6H5. These groups having minus I effect, because these are containing electronegative atom, and plus I effect containing group of atoms having plus I effect are any alkyl group, that is CH3, C2H5, CH3 whole twice, any alkyl group, always they have plus I effect. Okay, and the order of plus I effect: 3 degree alkyl group, that is CH3 whole thrice, greater than 2 degree alkyl group CH3 whole twice, greater than C2H5, greater than CH3. Next effect, and here one point is given: inductive effect is a permanent effect and decreases with increase in distance. Okay, now electromagnetic effect. What is electromagnetic effect? The complete transfer of shared pair of pi electron of a multiple bond to one of the atoms in the presence of attacking reagent is called electromagnetic effect. Electromagnetic effect, the complete transfer of shared pair of electrons of a multiple bond to one of the atoms in the presence of attacking reagent is called electromagnetic effect. And there are two types of electromagnetic effect. One is plus E effect and another is minus E effect. If the transfer of electron towards the attacking reagent, then it is known as plus E effect, and plus E effect is showing in this figure. You can see the transfer of electron towards attacking reagent H plus. Okay, so it is plus E effect. And second, minus E effect, it is if the transfer of electron take place away from the attacking reagent, away from, you can see here attacking reagent is Cn minus. Okay, so and transfer of electron away from Cn attacking reagent Cn minus, and that's why this is minus E effect. Next, resonance effect or plus R effect. What is the resonant effect? It is also permanent effect, electron displacement effect. The polarity produced in the molecule, by interaction of two pi bond and lone pair of electron present on an adjacent atom. Generally, resonance effect or plus R effect, it is also called R effect, or sometimes it is called mesomeric effect, which is represented by M. And resonance means conjugation between the pi electron and lone pair electron. Okay, here you can see acetic residing structure of or contributing structure of acetic acid. In acetic acid, structure is RC double bond O OH, and oxygen has two lone pair of electron. Okay, and oxygen and there is a conjugation between the lone pair electron on oxygen and carbon oxygen pi bond, and the C double bond O bond breaks, and O becomes O minus, and the oxygen of OH group converted into positively charged oxygen. Okay, and this displacement, this conjugation of electron throughout the structure is known as resonance. Okay, and these individual structures are known as in resonating structure or contributing structure. Here resonance effect in different compounds given, and based on resonance effect of different compound, there are two types of resonance effect. One is plus R effect, another is minus R effect. Some compounds showing plus R effect, and these functional groups are OH, OR, NH2, NHR, etc. These are showing plus R effect. Okay, and minus R effect like NO2 acid group, CHO, C double bond O, CN minus. Okay, these have minus R effect. And next type of electron displacement effect is hyperconjugation. It is a special kind of resonance in which delocalization of electron take place through overlap between sigma orbital and pi orbital. And it is also called no bond resonance. Here you can see this is a hyperconjugation. Okay, and it is actually conjugation between carbon pi bond and carbon hydrogen sigma bond. Conjugation between carbon hydrogen sigma bond and carbon pi bond. Now, IUPAC nomenclature of organic compounds. You have to follow some rules. Okay, following rules are used to write the IUPAC name of an organic compound. Rule 1, longest chain rule. First you have to find out longest chain. The chain containing the principal functional group, secondary functional group, and multiple bond, as many as possible is the longest possible chain. In the absence of functional group, in the absence of functional group and multiple bond, the chain containing maximum number of carbon will be the longest possible chain. In this example, you can see one acid group COOH group is present, and this is the principal functional group, and on left side there are 6 carbon, and on left side 4 carbon atoms, and on right side 6 carbon atom. And acid group is the main functional group. You have to mark acid group, the carbon of acid group, carboxylic acid group, that is COOH group, as 1. Okay, and there are two choices. The right side chain is longest carbon chain, which contains 6 carbon atoms, but on left side it contains 4 carbon atoms. Okay, similarly in this case, in this example, you can see which one is longest carbon chain. It is marked. And during naming organic compounds, you have to know about 3 terms. One is prefix, then root word, and then suffix. You have to use these 3 terms: prefix, root word, and suffix. Root word mainly indicates the number of carbon atoms present in the longest carbon chain. Okay, different root words are used for different carbon atoms, number of carbon atoms. For example, if only one carbon atom is present in the longest carbon chain, then you have to use root word meth. If 2 carbon atoms present, then eth. If 3 carbon atoms, then you have to use proof. If 4 carbon atoms present, then you have to use root word but. If 5, then pent. If 6, then hex. Like this. Second rule, lowest number rule. Numbering is done in such a way so that branching, if present, gets the lowest number. The sum of the number of side chain is lowest, and principal functional group gets the lowest number. You have to follow this rule during naming an organic compound. And now preference of functional group. Okay, select the principal functional group from the preference series. Acid group, then sulfonic acid SO3H, then ester group COOR, and then acid halide COX, amide CONH2, then cyanide, then NCCHO, C double bond O ketone, alcohol, thione, amine, and ether, then double bond, then triple bond. You have to remember this preference order. And rule 3, naming the prefixes and suffixes. In prefixes, mainly you have to use the name of side chain and name of halogen, halide, that is fluoro, chloro. Okay, there are 2 types of prefix. One is secondary prefix and another is primary prefix. Okay, so substituent prefix, if substituent F fluorine is present, then it is you have to use the prefix fluoro. If chlorine is present, you have to use the prefix as chloro. If bromine is present, then you have to use prefix if Cl is present, then you have to use chloro. If Br is present, then you have to use the prefix bromo. Okay, like if N double one N, then you have to use prefix diazo. Like this. If NO2 is present, then nitro. Okay, and primary suffix, these are secondary suffix, and primary suffix are in, N, or in used for double bond, single bond, and triple bonds respectively. These are primary suffix. In, N, and in used for double, single, and triple bonds. And secondary prefix, these are the secondary suffix, these are main functional group. Okay, and for different main secondary functional group, secondary suffix, different suffix are used. Okay, so if acid halide, in case of acid halide, formula is COX, like COCl, CO beer, If it is present as prefix, then you have to use the term halocarbonyl. But if acid halide present as main functional group or principal functional group, then you have to use the suffix oil halide. Second, if alcohol group is present, OH group, then you have to use hydroxy if OH is present as uh, primary functional group. Okay, and if OH is present as secondary functional group, you have to use the suffix ol. Okay, if aldehyde group CHO present, then you have to use Al as principal functional group. Okay, or secondary functional group. And if CHO group is present as a primary functional group, you have to use formyl chloride, carbaldehyde. For ketone, you can use oxo if it is present as primary suffix, or a on if the ketone group present as principal functional group. For amide, you have to use carbamyl, or for amide, if amide is present as principal functional group, then you have to use amide. For amine, amino or amine. For carboxylic acid, if carboxylic is present, then you have to use the principal suffix as carboxylic acid. Okay, like this you have to remember these points, name of this functional group. Okay, here according to rules given above, the IPSC name of compounds can be written as, first you have to write the name of a prefix, then root word, then suffix. And first you have to write the primary prefix, then secondary prefix, then root word like meth, eth, then primary suffix, and then finally secondary suffix. Here one example is given: CH3, CHOH, CH2, CHO. Here two functional group are present, one is OH, another is CHO, and CHO is a principal functional group and OH secondary functional group, primary functional group. Okay, OH and CHO is principal functional group or secondary functional group. So name of the compound will be 3-hydroxy. You have to write the name of OH in the prefix 3-hydroxy with its position. So 3-hydroxy is prefix and 4 carbon atoms in the longest chain, so but, and as the compound is aldehyde, so butanal. Okay, prefix, root word, and suffix. And if more than two similar functional groups are present, all the groups are considered as substituent. Okay, for example, CH2CN, CHCN, CH2CN, propane 1,2,3 tricyanide. Now naming of organic compounds or aromatic compounds, IUPAC accepted their common trivial names for aromatic organic compounds. Like for benzene, its name is benzene. For chlorobenzene, it is chlorobenzene. Benzene, above benzene, Cl. Above benzene, if CH3 is present, then it is known as toluene. If benzene containing OH group, then it is known as phenol. If benzene containing NH2 group, then it is aniline. Like this. Okay. And if CHO group is present, then it is benzoic acid. If CHO group is present in benzene, then it is benzaldehyde. Like this. Now purification and characterization of organic compounds. Purification and characteristic of organic compounds. First, lacine test for nitrogen. First you have to make the lacine extract or sodium extract. Then lacine extract is heated with ferrous sulfate solution in presence of alkali. The solution is cooled and acidified with dilute hydrochloric acid. If a green or blue coloration is obtained, it confirms the presence of nitrogen in the organic compounds. And the chemical reaction behind this test is sodium plus, you have to first make the sodium extract. So sodium plus carbon from organic compound and nitrogen from organic compound. Okay, so sodium plus carbon plus nitrogen, it combines to form sodium cyanide. And next step, sodium cyanide treated with ferrous sulfate, and it finally converted into sodium ferrocyanide. And again sodium ferrocyanide combined with Fe3 plus ions to form ferric ferrocyanide. And due to formation of this ferric ferrocyanide, we will get the Prussian blue coloration. Okay, and using this Lasine test you can identify, you can say whether nitrogen is present in the compound, organic compound, or not. Now formation of blood red color indicates the presence of both nitrogen and sulfur. Okay, formation of blood red color indicates the presence of both nitrogen and sulfur. Okay, when both nitrogen and sulfur are present in the organic compound, then in the Lasine extract you will see the formation of NaHCN, sodium plus carbon plus nitrogen plus sulfur. They combine to form sodium thiocyanide, and then this sodium thiocyanide reacts with Fe3 plus to form ferric thiocyanide, which is blood red coloration. Now detection of sulfur. If sulfur is present during fusion with sodium metal, sodium sulfide is formed like sodium cyanide. If sulfur is present, then in the Lasine extract you will get sodium sulfide. And this sodium sulfide, when treated with sodium nitroprusside, you will get violet color. Okay, so due to this formation of violet color, when Lasine extract is treated with sodium nitroprusside, if there is any violet coloration, then it is confirmed that sulfur is present in the organic compound. And second test with lead acetate. Okay, sodium sulfide when treated with lead acetate CH3CO whole twice Pb, you will get PbS plus sodium acetate, and due to the formation of this PbS, you will get black precipitation of PbS. Now detection of halogen using Lasine test, using Lasine extract. When the organic compound is fused with sodium metal, the halogen combine with sodium to form sodium halide. Okay, the presence of this halide is tested with a silver nitrate solution. Okay, when the sodium extract is treated with silver nitrate, if a white precipitate form, then which is soluble in ammonium hydroxide, it indicates chlorine. Okay, a pale yellow precipitate partially soluble in ammonia indicate bromine, presence of bromine, and a yellow precipitate insoluble in ammonia indicate iodine. Okay. If the organic compounds also contain nitrogen, sulfur, and sulfur, the sodium extract is first boiled with dilute HNO3 to decompose any cyanide or sulfide. Otherwise, this will form precipitate with silver nitrate solution. And detection of phosphorus, estimation of carbon and nitrogen. You have to remember these formulas of calculation of carbon, percentage of carbon, nitrogen in organic compound. First test, estimation of carbon and hydrogen. The name of the test is Liebig test, Liebig method. A known mass of organic compound is heated strongly with excess of dry copper oxide in a current of dry air or oxygen free from carbon dioxide. When carbon present in the organic compound is oxidized to carbon dioxide and hydrogen to water. And chemical reaction behind this test is are given here, you can see, and percentage of carbon and percentage of hydrogen you can calculate using this two important formula. For calculation of percentage of carbon present in an organic compound, the formula is 12/44 into mass of carbon dioxide formed divided by mass of substance taken into 100, and percentage of carbon 2/18 for carbon. It is for hydrogen, sorry, it is for hydrogen, not, it is not for carbon, it is for hydrogen. Okay. Hydrogen. So for hydrogen, that formula is percentage of hydrogen is equal to 2 by 18 into mass of water formed by mass of substance taken into 100. Now estimation of nitrogen, Dumas method. In this method also you have to treat the organic compounds with copper oxide, with copper, okay, copper oxide, and you'll get this reaction: C plus 2CuO heat, CO2 plus 2Cu, 2H plus CuO heat, 2H, H2O plus Cu. And if nitrogen is present, the nitrogen will react with CuO to form N2 plus small amount of oxide of nitrogen. Okay, an oxide of nitrogen combined with copper to form copper oxide and nitrogen. Okay, now we have to calculate the volume of nitrogen formed, and percentage of nitrogen is equal to 28 divided by 22,400 into volume of nitrogen in centimeter cube at STP divided by mass of substance taken into 100. And Gildel method, using this method you can also calculate percentage of nitrogen, and you have to remember the formula: percentage of nitrogen is equal to 1.4 into molarity of the acid. Here you can see in Gildel method sulfuric acid is treated with organic compounds, okay, and initially ammonium sulfate is formed, which is again treated with sodium hydroxide, which forms ammonia, and finally ammonia reacts with sulfuric acid to form ammonium sulfate. And percentage of nitrogen is equal to 1.4 into molarity of the acid into volume volume of acid used, volume of acid used into basicity of acid divided by mass of substance taken. This is the formula. Estimation of halogen carries method, and calculation of percentage of chlorine, which is 35.5 divided by 14.5 into mass of AgCl formed by mass of substance taken into 100. Percentage of bromine, 80 divided by 180 into mass of AgBr formed by mass of substance taken into 100. Percentage of iodine, similarly percentage of iodine is equal to 127 by 235 into mass of AgI formed by mass of substance taken. Percentage of sulfur, 32 by 233 into mass of BSO4 formed by mass of substance taken into 100. Okay, and estimation of phosphorus, one formula is given: 62 divided by 222 into mass of Mg2P2O7 formed by mass of substance taken into 100. Okay, and estimation of oxygen, one more formula is given. And method of purification of organic compound, there are different method: crystallization, sublimation, distillation. Just read thoroughly. Okay, fractional distillation, chromatography is a modern technique of isolation of compounds or separation of compounds. Okay, thank you students.